So study set 5, and then after we go over this, we'll talk about your celebration. And next week, next Monday. So just from the folks who were here early and going over the worksheet, I've been really impressed how fast, how well you're all picking this up. So I am sure it will feel like a celebration. Hopefully. We're using the ortho meta para. This is para when they're across from each other. So ortho is 1, 2, meta is 1, 3, and para is 1, 4. You can only use this with benzene. And that has to do because benzene is flat. It's because it's two-dimensional molecule, they have this OM and P. So this first one would be P. You can just write the letter P or you can write para. And we do put them alphabetical. So P dash bromo fluoro. It is technically one long word, benzene. B, this would be M, and we alphabetize it. So ethyl propyl. So this is just 3 carbons in a row, and then benzene. This one would be O, diethyl benzene. So we want to combine the two. And then this one, there are 2 different ways we can do it. So they're next door to each other. So you can, if you said O, dimethylbenzene, I would give you full credit. So if something like this showed up on Wednesday on the celebration, it was a question that was earlier, and you'll hear me say it, I'm sure, again today. Go with the one you're comfortable with. The other way to name it, though, dimethylbenzene has a common name, which is xylene. And so you're not responsible to know that. It would be O-xylene would be the other name. So it would not be named as a toluene. Toluene is when there's only 1 methyl. When there's 2, it goes to xylene. All right, number 2, again, aromatic means the benzenes, and they are not soluble because they are carbon hydrogen, unless we put start adding stuff to them. They are definitely less dense than water, and that is true. These are actually true for all the hydrocarbons. They are good solvents for nonpolar because they themselves are nonpolar, and they are not solids. Most of them are actually, a lot of them are liquids unless you got to really large ones. No, benzene's a liquid. All right, and then number 3. So start with your benzene. Probably one of the most missed things on the celebration, like it starts out like this where we draw them, is if I have you do a benzene, that you have to have that circle, and para means we're at the 1 and the 4. So they're just across from each other. I apologize. Let's see, there we go. Toluene, you can also, I like the circle, but you can also do the every other line like that. That's also acceptable. So a reminder, toluene is methylbenzene. And when it is named as toluene, oh, this is just saying this is going to be at number 2. So isopropyl is the peace sign. So wherever you put the methyl, you'll put that right next door to it. And then xylene, we just talked about up here, it's the dimethyl. And M just means they are 1 spot apart from each other. All right, and then, so I'm going to name them 2 ways. We're going to have to go alphabet. So bromo gets the 1. So you can do numbers. 1 bromo, 3 ethyl benzene. Or you leave off the numbers and it would be a meta. So M bromo ethyl benzene. This next one, the chlorine's going to get the 1, and the propyl would get the 4, or you can do para. So if you did numbers, you put a number before each one. So 1 chloro, 4 propyl benzene, or para chloropropyl benzene. And again, you don't have to say both ways. All right, on the next one, we have not, I don't know how to name this as a side group. So this is going to be my main part, is 1, 2, 3, 4, 5, 6. So this is going to be hexane. And when benzene is a side group, it is a phenyl. So it gets the YL ending. You do not want to say phenol. OL means an OH group, and that is something different. We're going to do those starting next week, next Wednesday. So again, this would actually be one word. So that YL, like methyl ethyl propyl. All right, and then this one, actually C and D, we can't use OM or P. So the OMP designation is only if there's 2 things. If there's 3 things, the way you number, the numbers have to be the lowest numbers possible. So the chlorine's going to be 1 and 2, and the bromine is number 4. If you made the bromine number 4, you would have a, I'm sorry, if you made the bromine number 1, you'd have a 1, 3, 4. And it's basically, if you added up all the numbers, you want them the lowest number combination possible. We do name the bromine first. These are all like minor little things, but that's what the rules are. 4 bromo, and then 1, 2 dichloro benzene. Any questions from the first page? All right. And now reactions. So reactions are great. I'm smiling because I wrote the rough draft of your celebration, and so the last page is the reactions. The good news is you guys, right, you're at home, so you just have to have nice clean notes. So toluene means that we have a methyl on there, and then plus chlorine, FeBr3, and it doesn't matter where you put the methyl, you are going to get multiple answers. So the chlorine is going to pull one of the hydrogens off. So HCl is also a product, but you can put the chlorine at the O, at the M, or at the P. When you write the chlorine, you write it. If there's nothing there, that stick means a methyl. There is one other product, only with the Cl2 ones, not with B. And that is that the chlorine could attach to the methyl. So yeah, there's our 4 answers. So OMP, or we could attach it to the methyl. All right, on the second reaction that these do, just write it as CH3Cl, that you have to remember every position here has one thing attached, which is a hydrogen. And this hydrogen is going to combine with the chlorine. So you get the HCl. Without the chlorine is basically how we're attaching carbon groups on there. The catalyst is shown on the line, and you can put the methyl anywhere. It's the same thing no matter where you put it, but we basically get toluene plus HCl. Wrote it way over there. So that is the answer to number 5. For benzene, it is a swapping. So you only add one thing. Only one chlorine is added or swapped. So it's swapping with a hydrogen. And that is called a substitution reaction. If it is an ene, if you truly have a double bond, it is a true addition reaction. And there is only one product. And you add both chlorines. So that's where we get the dichloros. Questions with that and the difference? Additions are like snap. You don't need, no catalyst is needed. They're extremely reactive. So these guys are highly reactive. Aromatics, they have to have a catalyst. And yeah. All right.
I have a question.
Go ahead.
So you, in example B, there was a methyl group attached to the benzene, right? Oh, there wasn't a methyl group. You're just showing that there's a hydrogen coming off of that, right?
Yeah. Yeah, I was just saying this hydrogen is going to go with the chlorine.
Oh, and then the methyl or the carbon with 3 hydrogens attaches to to that spot. Okay.
Yeah, so this would be the CH3 now, sorry. So like the one on the worksheet, Philip, it's a toluene you start with. So it'd be like on this one. So if you're adding, let's say, another methyl to toluene, it cannot go where the methyl is. It would have to go to O, M, or P, and it does not add to the methyl. It has to add to the ring at one of those positions.
Okay, got it. Thank you.
Yeah. All right, on number 6. Okay, somebody's cooking. Last Thursday I was teaching, and it's a longer class than this. It's like 104, where we never get done early, and there's always people in office hours till 9, and I was starving and there was no food. But I don't know which is worse right now, because they're making something extremely aromatic. Go figure. And so it's quite pleasant. All right. It's going to be a phenyl side group, every one of these on number 6. I personally, I'm not an organic chemist. There's fancy names for a lot of these chains, but in this case, it's easier to name this as pentane and to say the phenyl is at number 3. So here we go. Like if we had a methyl, and then this would be at 1 and 3. So we'd just say 1,3-diphenyl, and then butane. And then this one, that is a triple bond. So this is, you can tell that because there's only one hydrogen here. So this has to get the number 1, 2, 3. The triple bond does not have to be at number 1, but it has to be at the lowest number possible. So it is a 1-butyne. So that YNE tells us it's a triple bond. And then at number 3, we have a phenyl. And then technically there is a dash to run into the 1. So that is why on Wednesday, I will be on Zoom while you guys are doing your celebration. So if you have a question, you can pop on and say, hey, just double checking, that's a triple bond, right, on number 6C. And I can say, yes, it is. All right. So then on D, the side groups are at 2 no matter which way you go. And so the preference is the alphabet. So methyl comes before, M comes before P. So the methyl gets to be the 2. That is only if they're at equal distance. So it's not the size, it's the alphabet that determines it. This only happens, that dilemma only happens when there's an alkane. So this is just a pentane. Once we have a triple bond or a double bond, or actually after the celebration, it's never a dilemma again, because we're going to have O's, and the O's are always going to get priority, but a double or triple bond will take priority. You go with the alphabet determining the direction. If you're just dealing with a regular alkane, there's nothing special about it. So questions? All right.
So on number 6, when they're the side group, we do not use the ortho and meta.
You cannot, no.
Okay, that's all I wanted to know.
Yeah, and again, the ortho meta para, You could use them on these if you have two things attached to the benzene. But here, because the benzene's a side group, and actually back to what Christy just said, if this benzene like had a chlorine on it, I wouldn't actually know how to name this compound, because a phenyl can't have a side group. Yeah, they get into this really wacky naming way that we're not going to worry about. All right, and you can start appreciating like cartoons now. That there's some pretty fun organic cartoons. All right, I'm going to stop and